Well, we have question 5 here, and then in the previous videos, we did question 5.1 and 5.2. Now I'm going to do question 5.3, and the question says, determine the general solution of cos 2x minus 7 cos x minus 3 equal to 0. All right, I'm going to write the question here, 5.3. What we have cos 2x minus 7 cos x minus 3 equal to 0. All right. First, I think we need to expand cos 2x because it's a compound function. We do know that cos of 2 theta is equal to as 3 solutions. It is equivalent to cos squared theta minus sine squared theta, or it is also expressed by 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Now we can select one of the formula here to solve the problem. So I prefer to go with the middle formula, okay? Because the reason is that if I use this one, I'll have like the equation expressed in terms of cos of x, okay? So cos of 2x will be then 2 cos squared x minus 1. Okay, all this was cos 2x. Okay, minus 7 cos x minus 3 equal to 0. So this can be written like cos 2 cos squared x minus 1 minus 7 cos x minus 3 is 0. Now, is there any like term here? We can see we can combine the scalars, okay, the constant terms, -1 and -3. So all this will make 2 cos squared x minus 7 cos x minus 4 equal to 0. Now, we can solve this maybe like by factorization. Why? Because this is like a trinomial. Okay, it's a quadratic equation expressed in terms of cos x. So I can just to do that by trinomial, I can just do 2 times -4. Okay, and then this is equal to -8, right? I'll write -8 here. Now I'll write all the factors of -8, preferably the factors of 8, preferably in ascending order. They are like 1 and 8, 2 and 4. Now, if I need to make a sum that is equal to the coefficient of the middle term, I have to look with 2 and 4. I will never make -7, but with 1 and 8 I can if I do +1 and -8. Okay, so the same trinomial can be written as 2 cos squared x plus 1 cos x, okay, minus 8 cos x minus 4 equal to 0. Now we split the trinomial into 4 terms. Okay, if you struggle to see how to factorize, you can see have a playlist on question 1s. There we did so many questions on factorizations. So we factorize this like that. We split the 3 terms into 4 terms because you notice that 1 cos x and -8 cos x is just -7. This is just -7 cos x. Now the idea is to factorize by couples, okay? The first 2 and the last 2. So over here, you notice you have cos x, that's a common factor. And that cos x is a common factor. And then in the brackets, it will be, 2 cos x plus 1. So for the last 2 terms, also, this term and that term, I can take -4 as a common factor. And then this will be 2 cos x, 2 cos x plus 1 equal to 0. Now we notice that we have 2 cos x plus 1, 2 cos x plus 1 there. It has to be the same. If it's not the same, meaning either we selected the wrong factors of 8 over here, or we didn't factorize correctly over here. Excuse me. Now we can say, we can put cos x minus 4, open bracket, and then 2 cos x, okay, cos x plus 1 equal to 0. Okay, I'll remove my notebook over here. And then this means, you remember the properties, if we have like this term that equal to 0, it means that a cos x minus 4 equal to 0, or 2 cos x plus 1 equal to 0. Now, if we do cos x minus 4, we can move the 4 over, and then that makes cos x equal to 4, or 2 cos x equal to -1, and then cos x equal to 4. This is not applicable because remember the cos and the sines are all bounded, are all enclosed, okay, in between -1 and 1. They don't have values that they don't generate values that exceed +1 or below -1. Okay, so this is not applicable. You can check in the calculator. Okay, let's send the calculator to say error message. We're going to send the error message. And then if we want to work out the value of x, we need to press shift over here, and then press cos, and then press 4 like that, and then equal, you see, error, math error, because the cos and the sine, only cos and sine don't generate values that are more than 1 or lesser than -1. So we have left with 2 cos x equal to -1. So to find, that means cos x equal to -1 over 2. Yes, -1/2 is in between -1 and 1. Now, to find the x, we will use the same. We're going to press shift. We're going to calculate, press shift, and then cos, and then 1 over 2. This is for a special angle, and then this is equal to -1 over 2. So -1 over 2, close bracket, and then equal, this is equal to 120. So 120 degrees, x is equal to 2. Excuse me. That says that x is equal to 120. So that means 120 degrees. Now, 120, but now, this is not the final answer yet, okay? Let me first remind you something. I want to draw a trig circle over here for cos, okay? We know that cos is positive in the first and fourth quadrant, but negative on the second and the third quadrant. So it is negative over here and there also, because here we have like cos x is equal to -1/2. Now, when we work out this, we get x is equal to 120, so in the second quadrant. And it is also negative on the third quadrant. Now, on the second quadrant, maybe before even saying that I do that, I'm going to write here, I'm going to write over here. Over here, I'm going to write on the third quadrant, okay? On the third quadrant, I mean, second quadrant, sorry. Second quadrant. Because cos is negative on the second quadrant, we got x equal to 120. If we press S, we need the calculator. Okay, we got here x is equal to 120. So now we're going to say 120 degrees plus 360 k, where k is an integer. Okay, that's for general solution. We use the k because every 360 degrees it comes back to the same answer. So now on the third quadrant, then where cos is negative also, I don't know why. Okay, third quadrant. We're going to do a 360 minus 120, okay? So this is equal to 240. So this x will be equal to 240 degrees plus 360k. And k is still an integer. So these are the general solution. This one. And that one. Thank you.